Alright, beta, chaliye, let's start. We are starting a new chapter today in chemistry. Name of the chapter is mole concept and stoichiometry. Alright. And under this heading, let's start the first topic. Now, before starting, let's repeat gas laws. Gas laws, we did this in class 9. Let's discuss the gases again. What are gas laws? There are two gas laws, Charles' law and Boyle's law. Please come to page number 70. Charles' law and Boyle's law. All the gases follow certain rules. All the gases follow certain. Let's see what are these rules. First is Charles' law. Robert Charles, you remember class 9? Robert Charles said that at constant pressure, volume of a given mass of dry gas is directly proportional to temperature. Is what proportional to temperature? Directly proportional to temperature. Means if we increase the temperature of a gas, its volume also increases. And you already know it. किसी भी गैस को गर्म करिए आपको पता चलेगा कि वो एक्सपैंड हो रही है, ठंडा करिए तो कॉन्ट्रैक्ट होगी. Not only gases, सब में होता है. Clear? Second, then it is what law? Boyle's law. What is constant? Yes. Here we keep pressure constant. And Boyle's law, we keep what constant? Temperature constant. And here, volume is very good. Inversely proportional to. Now, when we further solve this data, V is directly proportional to T, means V upon T is constant. What? V upon T means if we increase the temperature, volume also increases, but the ratio always comes same. And let's consider a case of volume and temperature. Let's say if volume was 100, when temperature was 10, what will be the ratio? V upon T. 10. Very good. When I increase the temperature to 20, volume will become 200. Because when I increase the temperature, volume also. Temperature बढ़ाते हैं, गैस को गर्म करते हैं, तो फैलती बड़ी हो जाती है. 200 upon 20 will be what? 10. That's right. If I make the temperature 30, this will become 300 automatically. And they all will be in proportion. 10. So the formula comes out to be that volume of first volume at first temperature and second volume at second temperature, the ratio will always be same. V1 upon T1 equals to V2 upon T2. Same with Boyle's law. If I take pressure up, it will say that PV is always constant. Because they are inversely proportional. Let's see what happens. If I increase the pressure, volume decreases. Pressure, volume, PV. Let's say pressure 10, volume is 10, PV is 100. Let's say I'm doing pressure half. Pressure को मैंने आधा कर दिया. कितना कर दिया? 5 कर दिया. अगर प्रेशर आधा किया है तो वॉल्यूम कितनी डबल हो जाएगा? इनवर्सली. इसको आधा किया तो डबल हो जाएगा, मतलब 20. फिर प्रोडक्ट कितना आएगा? 100. मान लीजिए हमने प्रेशर को डबल कर दिया, दुगना प्रेशर लगा दिया, तो वॉल्यूम आधी हो जाएगी. आधी मतलब 5, फिर 100 आ रहा है, मतलब P into V हमेशा वही आएगा, कांस्टेंट है P. तो फॉर्मूला comes out to be first pressure into first volume will be same as P2 into, and then if nothing is constant, then we get the gas equation. And gas equation is nothing but the combination of these two, Charles law and Boyle's law, right? And it says P1 V1 upon T1 equals to P2 V2 upon T2. We will be using this equation in some questions. And I told you PVT याद रखिए. PV क्या P आपने सुबह सुबह T याद है? PVT. If pressure will be constant, will not consider pressure. So formula will become what? V1 T1 equals to V2 upon T2. If let's say temperature is constant, then we'll not consider the temperature, and formula will be P1 V1 equals to T. Is this clear? Page number 70 clear. Now let's discuss the main topic. Please write down the heading in your notebooks. All of you should copy this as well. Copy beta. All of you should copy quickly. So this is gas equation. Now write the most important law beta. The first law that we are going to discuss in class 10. Write down. Right. Gay-Lussac law. There were times when people used to name their children gay. Good times. But now, now people have changed meaning of words. Society is on the verge of destruction. Very bad. So his name was gay, and then gay means happy, right? And he gave a law. What law? Lussac gave a law. And he said, now please listen to this carefully. He said, when gases react, let's take one example of gases reacting. N2, or easy example. Okay, N2 plus H2 gives NH3. कुछ याद है अमोनिया? अमोनिया की मैन्युफैक्चर? हाँ बिल्कुल सही. ली-चैटलेट्स प्रिंसिपल क्या लगता है इसमें? N2 plus H2 gives NH3. This is not balanced. Let's balance it. 2 and then 3. Now, this is very fascinating. समझ के देखिए बहुत मजा आता है इसको सुनने में. Lussac said, when gases react, जब gases जुड़ेंगी, मिलेंगी, mix होंगी आपस में, they do so in volume. ये volume में करती है काम. तभी तो हमने volume के laws पढ़े हैं. That volume is directly proportional to temperature. Volume is inversely proportional to pressure for a gas. He said when gases react, they do so in volume, which bears a simple whole number ratio to each other and to the reactants. अब इसका मतलब क्या हुआ? ध्यान से सुनिए. This here we have nitrogen N2 is only one molecule, so we call it one volume. Ratio 3 volume will produce 2 volumes. Now, you know it bears a simple number ratio to each other and product. का मतलब ये हुआ रेशियो हमेशा सेम रहना चाहिए. अरे अगर रेशियो सेम रहना चाहिए तो उसको तो कुछ भी लिख दीजिए. मान लीजिए अगर ये 1 लीटर बॉटल में लाया, 1 लीटर कोल्ड ड्रिंक की बॉटल में लाया, ये सामने 1 लीटर रखिए. 1 लीटर बॉटल नाइट्रोजन की लाए और 3 लीटर्स ऑफ हाइड्रोजन लाए. सो आइडियली 1 लीटर में 3 लीटर डालेंगे तो कितना बनना चाहिए? 4. सिंपल बात है. कीपिंग द टेम्परेचर न्यू बॉटल में डालेंगे. भाई पानी का गिलास अगर आप 1 लीटर और 3 लीटर पानी लाए, मिक्स करेंगे तो कितना बनेगा? नई बॉटल में डालेंगे. वैसे जब हम यहाँ पर हम लाए 1 वॉल्यूम, constant temperature and pressure. What? If the temperature is constant and pressure is constant, then volume of a gas remains constant. ऐसा नहीं सोचेगा. देखिए यहाँ पर अगर हम गैस को रिलीज करते हैं अभी रूम के अंदर, its volume will start increasing. परफ्यूम लगाते हैं आप, गैस में कन्वर्ट होता है, volume increases. Yes or no? Right? But in case if pressure and temperature is constant, then gas remains same, intact. गैस का उतना ही वॉल्यूम रहता है, बढ़ता नहीं घटता नहीं. वो यहाँ पर हो रहा है. But he said when gases react, they do so in volume, which bears a simple number ratio to each other and to the product. मतलब अगर आप 1 वॉल्यूम 3 वॉल्यूम से 2 वॉल्यूम बन रहा है तो हमेशा यही होगा. अगर आप 1 लीटर नाइट्रोजन लाए, 3 लीटर हाइड्रोजन लाए और उन दोनों को मिक्स कर दिया तो सिर्फ 2 लीटर अमोनिया कम हो जाएगी. If you keep the temperature and pressure constant, कम हो गया, वॉल्यूम कम हो गई और सारी गैसेस में लगेगी. If reactants and products both are what? Gases. Any hydrocarbon when burned, कोई भी hydrocarbon जिस मीथेन को जलाते हैं CH4 जलाना मतलब ऑक्सीजन के साथ बनता है CO2 if it is complete bonding H2. Carbon is balanced. Oxygen is balanced. No, you have to put a 2 here. CH4 होगा सर. CH4. Hydrogen is balanced now. Yes or no? Oxygen, I'll put a 2 here. Is it balanced now? Carbon is balanced. Hydrogen is balanced. Balancing की problem होगी भी तो balance करके भेज रहा कौन balance कर सकता है इसे
Sir, it will remain CH4 only.
Okay, it will remain CH4 only and is it balanced now? So 1 volume of methane plus 2 volumes of this will give 1 volume of this and 2 volumes of water. So here it is fine. Yes or no? आपको ऐसा लग रहा होगा भाई 1 लीटर में 2 लीटर डाला 3 लीटर ही बन रहा है इसमें ठीक है बट इधर देखिए क्या हो रहा है थोड़ा प्रैक्टिकली ठीक लग रहा है वॉल्यूम कम हो गया बट दिस इज व्हाट Lussac said Lussac because volume of gases are not constant they keep on changing we cannot consider them like volumes of liquids or solids they change गैस की वॉल्यूम बदलती रहती है अगर आपके पास 2 लीटर अमोनिया उसका टेम्परेचर बढ़ाइए वो 4 लीटर हो जाएगी एक्सपैंड हो जाएगी उसका प्रेशर रिलीज कर दीजिए वो और एक्सपैंड हो जाएगी yes or no so Lussac said when gases react they do so in volumes में करते हैं volumes में which bears a simple rule number ratio to each other and to the what product provided temperature and pressure remain constant. Let's jump to the numericals. Quickly write down the array. Numericals. Yes, beta.
सर फिर इसके साथ सर लॉ ऑफ कंजर्वेशन ऑफ मास अप्लाई नहीं करता
बिल्कुल करता है लॉ ऑफ कंजर्वेशन ऑफ मास अप्लाई कर रहा है बैलेंसिंग चाहिए मास अप्लाई करता है लॉ ऑफ कंजर्वेशन ऑफ वॉल्यूम नहीं होता कुछ भी लॉ ऑफ कंजर्वेशन ऑफ मास अप्लाई कर रहा है नाइट्रोजन ऑन द लेफ्ट साइड आर 2 राइट साइड आल्सो नाइट्रोजन आर 2 mass is conserved nitrogen hydrogen 6 mass is conserved because you have balanced it yes or no right beta
yes sir
but there is no law of conservation of volume there is nothing like law of conservation of volume okay so
yes,
Lussac said whenever gases react they do so in volumes which bears a simple number ratio to each other and to the product मतलब अगर 10 लीटर अगर नाइट्रोजन ले आए तो कितनी हाइड्रोजन यूज कर लेगा वो 30 लीटर्स और फिर अमोनिया कितनी बनेगी 20 लीटर्स 10 टाइम्स हो गया अगर इसको 20 टाइम्स कर दीजिए 20 लीटर नाइट्रोजन आ गया तो वो भी 20 टाइम्स हो जाएगी they will bear the same ratio 100 लीटर ले आए आप नाइट्रोजन तो हाइड्रोजन कितनी होगी 300 और वो बनेगी 200 लीटर तो क्या चलेगा सेम 1:3:2 1:3:2 and this is how we do the numericals also by using this concept that ratio will always remain what same this is clear ratio will always remain same please come to page number 71 let's check the law when gases react they do so in volumes which bear simple whole number ratio to one another and to the volume of the product if gases provided the temperature and pressure of the reacting gases and product remain constant. First place, all the reactants and products should be gases. These laws will be applied only on what? Gases, not liquids and solids. Second, the temperature and pressure throughout should remain what? Constant. आप उसको बड़ा घटा सकते नहीं बताइए तो क्लियर आगे बढ़े let's start the numericals. Now page number 72 first numerical let's see here check quickly first numerical beta it says 450 centimeter cube of carbon monoxide all of you know what is carbon monoxide CO the volume of CO is given as what 450 centimeter cube all right then and 200 centimeter cube of oxygen. Volume of O2, 200 centimeter cube, are ignited. Please remember, whenever you're igniting something, it means it is combining with oxygen. And moreover, whenever we burn a carbon product, carbon dioxide is formed. Whenever we burn a hydrogen product, water is formed. Whenever we burn something which is made up of carbon, carbon dioxide is formed. And if it is made up of hydrogen, what is called? Water. But if it's a hydrocarbon, हाइड्रोजन कार्बन दोनों है उसमें, सो कार्बन डाइऑक्साइड और वाटर दोनों बनते हैं, बट यहाँ पे H नहीं है, सिर्फ C है, सो CO2 बन जाएगा. सिंपल. लेट्स बैलेंस द रिएक्शन 2 and 2. Now listen to this carefully, beta. Please copy it later. Please listen carefully. Let's find the ratio. This is 2 volumes.
1 volume.
Ratio 1 volume,
It's 2 volume.
2 volumes. Now this says that if this is 2 something, then this will be 1 time of that thing. Ratio is 2:1. That will always be double of what the second one is. And product will also be only 2. Clear? Now, let's see how much do we have. Total volume. I'll write like this. Total volume of CO is 450 centimeter cube. Total volume of oxygen is 200 centimeter cube. Is this clear? Now, whenever we react with our two things are reacting, then the amount of reaction means how much product will be formed depends on the reactant which will get exhausted first. How much reaction will happen depends on which reactant which will get exhausted first. जो भी reactant पहले खत्म होता है उस पे depend करता है reaction, and the other reactant will be left unused. ये तो होगा. मान लीजिए मैंने आपको दिया है एक स्विमिंग पूल भर के पानी दे दिया, फ्रेश वाटर आपका आर वाला, और 2 शुगर दे दी, समझे, रसना बनाने के लिए. और रसना के लिए बस एक ही पैकेट दिया, पूरी नदी दे दी मान लीजिए आपको पानी की, फ्रेश वाटर की नदी दे दी. चीनी की पूरी खेत दे दी करने के, कितनी चीनी निकाली, बट रसना का पैकेट बस एक ही दिया है जिसे 1 गिलास बनता है. तो कितना रसना बन पाएगा? एक मैक्सिमम खींच के 2 बना दीजिए. नहीं बना सकते, नदी बह रही है, चीनी रखी हुई है, रसना नहीं बनेगा. सो मिनिमम जो रिएक्टेंट होता है उस पर डिपेंड करता है बेटा प्रोडक्ट बनेगा कितना. अब देखिए आपके पास मिनिमम कौन है? हाँ, उतना वॉल्यूम. अब मिनिमम बताइए क्या? ऑक्सीजन 200 है, ऑक्सीजन इज 200, कार्बन मोनोऑक्साइड इज व्हाट? 450. सो मिनिमम कौन है? आप देखिए ऑक्सीजन है, इसका मतलब पूरा ऑक्सीजन यूज हो जाएगा. यूज्ड वॉल्यूम ऊपर लिखा हमने टोटल वॉल्यूम, नीचे लिख रहे हैं हम यूज्ड वॉल्यूम. अब देखिए 201 कितने से 200 होता है? दिस इज वेरी इंपॉर्टेंट, प्लीज चेक. 1 200 is 200. If this is 200 times, so everything should be 200 times. Only Lussac's law can be applied. Lussac said, whenever gases react, they do so in volumes. They are reacting. Their ratio should always come what? Same. Means if oxygen is 200, carbon monoxide should be 400 because the ratio should be 2:1. So इसका डबल होता है कार्बन मोनोऑक्साइड. फिर से समझिए, हमने ऑक्सीजन को नॉर्म क्यों माना बेटा? ऑक्सीजन 200 था, आई टोल्ड यू. वो रिएक्टेंट जो सबसे पहले एग्जॉस्ट हो जाएगा, खत्म हो जाएगा, उसी को तो कंसीडर करें. बाकी दोनों रिएक्टेंट तो कितने भी रहे, रिएक्शन हो गई. सो 200 था, ये 200 कितना है? 1 into 200 is 200, and the other one is also 200 then, and this will also be 200. 400 centimeter cube. Now unused बचेगा. टोटल कितना था? 450. यूज कितना हुआ? 400. सो 50 सेंटीमीटर क्यूब अनयूज्ड हो गया. ये अनयूज कितना बचेगा? 0. 200 था, 200 का 200 यूज हो गया, और ये तो प्रोडक्ट है बन गया. पूरा लिखते हैं. This is calculate the composition of the resulting mixture. We have to find the whole resulting mixture. Resulting mixture will be having resulting mixture जो बचा कुचा सामान होगा सबसे पहले उसमें होगा unused what CO जो जली नहीं है कितनी होगी 450 minus 400 will be 50 centimeter cube. Then we will have produced CO2 and which is 400 centimeter. Now please listen to this carefully. Your teachers may teach you this by unitary method, where they write 200 centimeter cube produces this like it's given in the book. It's not given in the book also, but this method is 100% correct. This method is 100% correct. And in case if a teacher is saying, let's say that do only by unitary method, then I can't take it. I'll teach you unitary method, but this method is acceptable in boards and it is very easy. No questions, don't worry, copy this one. Now,
Sir.
sorry. So this is the answer, 400 centimeter cube. Let's do the next question. Question number 2. All of you understood this one? Let's do question number 2. Question number 2 is 1 volume of nitrogen. Okay, 1 volume, they are giving the balanced equation. 1 nitrogen combines with 1 volume of oxygen. Oxygen we know is O2, oxygen gas. Its atomicity is 2 to form 2 volumes of nitric oxide. Nitric oxide means not nitrogen dioxide, nitric oxide, NO. Calculate the amount of each reactant required to produce 250 ml of nitric oxide. Now, total amount of this is given. The product is 250 ml. This is the question. All right. Understood? Now, let's write what Lussac'S said. Lussac'S said, this is 1 volume. This is 1 volume. This is 2 volumes. So we will have 1 times. This will always be 1 times. And this will be 2 times of the reactants. Now, we have only this given, 250. So 250 will be used. 250 will come, and this is 2 into what? 125 times. If this is twice of 125, so everywhere you have to put 125, so that the ratio remains same. This is Lussac's law. तो वॉल्यूम का रेशियो है वो सेम है देखिए 125 125 125 चेक बेटा व्हाट इज द रेशियो हियर यहाँ पे क्या रेशियो है ना 1:1:2 so even here it has is it coming same 1 1 2 3 125 ones up 125 ones up 125 twos up so 125 1 125 1 so we'll write amount N2 used is 125 ml and amount of O2 used is 125. Good? Easy. Yes, we are writing these volumes from the equation. Like this is 1, this is 1, and this is 2. So 1 volume, 1 is 2, 1 volume gives 2. Any doubt? Copy quickly, it was easy. Now I am giving you the third one for homework. Please try this question 3 on your own. And even unused, nothing is unused. One reactant is given. Unused will be left when there are 2 reactants. जब 2 reactants होंगे तो दोनों में से एक तो कंज्यूम हो जाएगा पहले और एक अगर कंज्यूम हो गया तो फिर दूसरा ही बचेगा ठीक दूसरा थोड़ा बच वो एग्जॉस्ट हो गया चलिए लेट्स सी क्वेश्चन नंबर 4 ओके आई एम डूइंग क्वेश्चन नंबर 4 हियर copy quickly beta then you do question number 4 I am reading the question for you 3000 centimeter cube of oxygen was burned with 600 centimeter cube of ethane. Now although we don't know what is ethane right now but we know when we'll do organic chemistry and you can even write the formula in. Done? Okay, good. Now do with me. Let's see. 300 centimeter cube oxygen was burnt with carbon. Ethane is C6. Burning means it is, yes, burning means it is combining with oxygen. Oxygen, okay. Carbon means carbon dioxide. Hydrogen means water. H2. Huh? 3000, right? What? Now just balance it. It should be 2 times 2 2s are 4. If it is 4, then it will also be 4 here. And then oxygen will be, this is O. We'll make it even by 6. And then this will become 7 to the 14. Balanced? Balanced? Do try on your own. Do the initial part of your own. Write down the volumes. Okay. And then at the top, write down the total. Then try to write down the given. Quick. Try. How much volume? What is the ratio? Easy. And then write the second line. Make the bracket. And then this into this into this into. So it's coming like this is 2 volumes. You know, I write 2 volumes here. Ratio, how much? 7 volume gives 4 volume. Ratio 6 volume. So this would be 2 into. First one should be 2 into. Second one should be 7 into. That's a big number. This will be 4 into, and the fourth one should be 6. Now there is a problem again. We have 2 reactants. Oxygen is 3000 centimeter cube. Total is 3000. The other one is how much? How much? 600.
600.
Now it is, yes, beta. Now it is clearly visible which gas will get exhausted first. Think ethane. Yes or no? So we'll take that as given, 600 centimeter cube. And 2, how much is 600? 2 into 300. Now if you have multiplied 300, if this gas you are taking 300 times, the gases should be taken how much? 300 times. This is clear. So oxygen used would be 2100. This would be 1200. This would be 1800. That's it. How much unused will be left? Unused is always valid for reactants. 3000 we had, 2100 is used. How much is left? 900 centimeter cube. 600 we had, 600 is used, 0 left. Unused will be only reactants because they are using the reactants. Unused मतलब जो बच जाएंगे. Easy लग रहा होगा? Difficult तो नहीं लग रहा बेटा अभी तक? It's very easy. Now write down. Question says, calculate the volume of oxygen used only. So volume of oxygen used is how much? 600 centimeter cube. Now please remember. Understood? Volume of oxygen. Unused oxygen, sorry, not used. It says unused oxygen. How much unused oxygen is there? 900 centimeters. Now please listen to this carefully. This is very important. We will consider water as a gas only if temperature is what? 100 degrees Celsius or maybe beyond that. Generally they'll write temperature is 500 degrees. Then only we'll take water as a gas. Otherwise, this is not considered. If the temperature of the reaction will decrease, then water will condense to form liquid water. If you 100 or so ऊपर तो water vapor रहता है. Water vapor रहते तो क्या होगा? Solid or gas? Or liquid? Gas. Then Lussac'S law can be applied. But if the temperature is less than 100 degrees Celsius, water cannot follow what? Lussac'S law. Is this clear to you? We have done it very slowly. The first set of questions that I wanted to teach you. Please take example 5 for homework. Do them today, okay? Example 5 for homework and example 6 for homework. Example 5 and example 6 are for homework. Or we can try it. Let's see example 7 and this will be the last question for today. Example 7. Copied? Or we've done this? Why did I put a cross on water?
Yes.
Because the final temperature is not 100. So water tends to form liquid. All right. And if it is condensing to form a liquid, it will not follow gas laws. We mean Lussac's law because it is applicable only to gases. Let's do question number 7. जो फाइनल टेम्परेचर अगर बर्न कराए ऑब्वियसली वो तो ज्यादा जाएगा और पानी सारा वेपर फॉर्म में बनेगा बट फाइनल टेम्परेचर रिएक्शन होने के बाद अगर ठंडा कर दिया है तो फिर जीरो हो जाएगा वाटर को नहीं कंसीडर करेंगे फिर हम इवन रिजल्टेंट फाइंड द रिजल्ट विल नॉट राइट वाटर we'll write water only if it says what final temperature is 100 and we'll be doing those questions tomorrow and we will close Lussac's law tomorrow. Please do the homework questions today. We'll close Lussac's law. It's that easy. You will surely get a question from here in exam. Question number 7. Calculate the volume of oxygen required. Listen. Calculate the volume of oxygen required to burn completely. 22.4. Total we have 22.4 decimeter cube methane CH4 and if I am burning methane it means it will combine with oxygen to give me CO2 plus H2O. How will I balance this? H is not balanced so 2 to the 4 balanced and this will also have what? 2. Is it balanced now? So we'll have one volume ratio 2 volumes will give how much? 1 volume plus ratio 2 volumes. Now, although we are burning one more product, but I am going to burn one at a time. I am going to consider one at a time. Although we are burning and it says hydrogen also, but I am not reading hydrogen. Let's burn methane first. How much methane do you have? 22.4. So this should be 22.4. Whole used, only one reacted. Oxygen is infinite then. So 122.4, 222.4, 122.4, 22.4. We have to find only what? Oxygen used. Product, the question doesn't say find the product. So we are not product. So how much oxygen O2 used in burning methane? How much O2 is used? 44.8 decimeter. Yes. My question says that for one volume of CH4 you need 2 volumes of oxygen. Double oxygen चाहिए. तो अगर आप 22.4 लाए तो 44.8 होना चाहिए. बच्चे तो इसको verbally कर देते हैं. Second one is 2. If I burn H2 plus O2, hydrogen है तो बस water बनेगा. कार्बन है तो CO2 बनता है और अगर C कार्बन हाइड्रोजन दोनों का प्रोडक्ट है तो दोनों बनते हैं. Right. So let's see here. Let's balance it 2 times. This will also be 2 times. 2 volumes is to 1 volume. Gases, when gases react, do so in volumes, which bears a whole number ratio to one another and to the product. You should learn this law also. No need to write any statement directly. Hydrogen is how much? 11.2 decimeter cube. 11.2 decimeter cube. So this will be how much? 5.6. Everywhere 5.6. How much O2 will be used then? 5.6. So O2 used to burn what? How much? H2 hydrogen. It is coming as 5.6 decimeter. So I'll write total O2 used would be 44.8 decimeter cube plus 5.6 decimeter cube. Add it, you'll get 4. How much? 50.4. 50.4 decimeter. Is that clear? And 1 decimeter cube means nothing but liters.
Sir.
Right? Yes, please wait. So, beta, this is Lussac's law. When gases react, they do so in volume, which bear a simple whole number ratio to each other. Now, tomorrow means in the next one, you will find some complicated questions where the temperature or pressure of the gas may change, and that's very dangerous. If I'll change the temperature or pressure of methane, like it is 22.4 liters, if I change its temperature or pressure, its volume will change. So we cannot take 22.4 liters. That's a problem. If I change the temperature, let's say I'm increasing the temperature, its volume will increase. If I'm increasing the pressure, its volume will decrease. So that's how we do questions of Lussac law, and this is what Lussac law tells us. So that's it. Rest we'll check in the next one.